Welcome everybody to our first edition of Virtual Thursday 2020. We're going to cover hydrant flow testing today. Hope everyone had a Merry Christmas and a Happy New Year. And I wanted to give a shout out to a few of our attendees today. I did see that we have Todd Russell attending from Palmer, Alaska, and Fire Marshal Jeff Hilvers in Trotwood, Ohio, just down the road from me. And also we have Andrea and Katie from our emergency reporting marketing department out there lurking along with the rest of you attendees. Thanks for attending, ladies. If you do have a question while we're going through the presentation, please don't hesitate to post it into your chat, and I'll take care of them as quickly as I can if they come in. And I appreciate you too posting up that I failed to turn on my sound, my audio. Thank you. My name is Mark Wolf, lead international trainer for emergency reporting, and a brand new regional trainer was supposed to be attending with us, James Angaret. He got actually detailed to do some other onboarding thing. Today is actually his first day at work as a regional trainer, and we're welcoming him. He may drop in later if he gets a few moments to do so, and we'll have him introduce himself to you folks. I want to remind everybody about our training opportunities. Virtual Thursdays, they're free. You know the good old saying, if it's free, it's for me. So here you go. First Thursday of every month at 1100 hours Pacific time. Adjust your time for the start to your time zone. We do offer online training in 3-hour blocks. We can customize those to meet your needs. We do offer on-site training. And speaking of on-site trainings, we are very, very busy. So if you're anticipating having a on-site training this year, please contact us and get that scheduled as early as possible. Our training coordinator, Nicole Beard, will be happy to get you a quote out for the online training and the on-site training and our regional training academies. And let's go through a little list of those right now. First, we're going to be down in Corpus Christi, Texas next week. After that is our Ultra Secure Regional Training Academy. That's for our ultra secure customers only out in California in February. Jacksonville, Florida, March 17th through 19th. Kansas City, Missouri, April 7th through 9th, and Spokane, Washington, May 5th through 7th. And in fact, all of the virtual regional training academies are published in our Eventbrite webpage. I just don't have these advertising slides as of yet to put them in here. However, you can go to this website, emergencyreporting.eventbrite.com, and check out the locations and see if there's one close to you that we'll be presenting at. You can also go on our website at emergencyreporting.com, go to the customer success section, the training and learning center to learn more about our regional training academies, and there's our email address to get to the entire training team, training@emergencyreporting.com. So we're going to go ahead and jump right into it. Testing fire hydrants. This is specifically flow testing fire hydrants. And you'll find out in a little bit here when we actually get into doing that. Hopefully you've experienced that and had good experience doing it in emergency reporting, is that we follow the NFPA 291 recommended practice for fire flow testing and marking of hydrants. I have a few slides to review before we actually get into a short little demo of entering a flow test for you. We're going to go through not all of the sections, but we're going to go through the important sections. And in section 4.1, rating the pressure, there's a few important sections to talk about here. We base our residual pressure on 20 pounds per square inch, and we try to maintain that, as you see in 4.1.3. When we are doing that, that is a default setting in the system, but alas, you can change that if you have a local need to do so, or if your static pressure is less than 40 pounds per square inch, you're supposed to rate the hydrant at 1/2 the static pressure for your residual pressure. And just for safety and security of your water system, you want to maintain a sufficient residual pressure to prevent a negative pressure at any point in the water system. That's one reason why they have that benchmark of 20 psi. And section 4.2, the procedure. A couple things are important to measure here, that we want to make the test during ordinary demand. so that it's a good test of your system. You don't want to overload the system, turn extra pumps on and so forth. You want to have a realistic test bed out there to get your pressure readings from. And 4.2.2, you want to discharge that water. What we want to do is at a measured rate of flow at a given location and observe the pressure drop. And that whole formula revolves around that particular section. And I'll show you that formula here in a little bit. The layout of test. So typically what we want to do is follow a few guidelines when we're doing the flow testing. First of all, we need to select a location and a group of test hydrants. And you'll designate one of those hydrants as what we would call the test hydrant. And that is where our static and residual pressure would be recorded. Then what we want to do is test the hydrant that's located between the flow source and the flow hydrants. And I'll show you a little diagram that I cooked up here in a little bit to demonstrate what we're talking about here. And as you can see in 4.3.5, the number of hydrants that we're going to use in our test depends on the strength of the water supply system for that locality. And you'll see you may need to open and flow more than one fire hydrant to get really good test results, which, by the way, is what 4.3.6 instructs us to do. Is what we want to do is get a 25% drop for that residual pressure for the best test result. So if we have, as you'll see later on from my example, we have a static pressure of 50. So we want to achieve a residual pressure at least 25% below 50. And in that case, it's 47 or 37.5 psi at that test hydrant to get good test results. So here's a few layouts of a typical hydrant test from a very, very simple, as in a dead end main. The R indicates the hydrant that we would get our residual pressure readings from, and the F1 or F2, so forth. Those are our flowing hydrants that we will use to obtain a pitot pressure reading while we're obtaining that residual pressure reading from our actual test hydrant. These are just some simple layouts that they give us in NFPA 291. Of course, at your particular location, you may have to put some more thought into this, knowing your local water system, how strong your grid is, and where those grid pipes are laid in your community. So what kind of equipment do we need? Section 4.4 addresses that. Well, we need at least a hydrant cap with a 200 psi pressure gauge with a bleeder on it. That bleeder is very, very important. Sufficient number of pitot tubes with gauges and also bleeders on those. Sufficient number of hydrant wrenches to operate the fire hydrants, and it works best if we have some portable radios for communications to talk back and forth, because in some cases our distance between these hydrants is going to be so far that maybe voice commands won't be heard naturally, or even you may be out of sight from the test hydrant, so hand signals may not work too well for you. So a basic test procedure is you want to attach that hydrant cap with a gauge to the test hydrant. You want to open that bleeder and then open the hydrant. That's to exhaust all the air in there. The air that's left in that barrel of the hydrant can act as a shock absorber and give you false readings at that test hydrant. So you always want to open that up and exhaust all the air from it. Then we want to take and record that static pressure. And then we will open flow hydrants in succession as needed to get that test data that we need. And remember, we are going to achieve or need to achieve a 25% pressure drop at our test hydrant from static pressure to residual to get good readings, and it'll give us more accurate results. So again, we're going to open those hydrants one at a time, and we're going to watch that pressure drop at the test hydrant until we get at least that 25% minimum drop, and you'll get the optimal results if you can get that residual pressure all the way down to 20, which in some cases may be pretty difficult. However, that's what we're looking to achieve. So you want to take and record those pitot pressures at the flow hydrants And once we get that 25% drop from the static pressure to the residual pressure, we don't have to open any more hydrants. So then we want to jot all of those pressures down from our pitot pressures at the flow hydrants and our static and residual pressure, and retain those. And then we will go in and record them. So our pitot readings, typically what we want to use is the 2.5-inch outlets on the fire hydrants. The pumper outlets, which is typically the larger outlet on most hydrants, generally won't give us good results in our pitot tube because of the volume of the water coming out and the size of that stream. So if we use those 2.5-inch outlets, it's going to work out better for us. And we've got a little diagram here of how we need to position our pitot gauge. We want to make sure that as we're positioning that and you're actually conducting the test, that you keep the handle uphill from the water stream and use that air release caulk on there to, again, relieve all the air from the pitot gauge to because that acts as like a shock absorber in there, and that can get you better test results when you do exhaust that air. You also want to try to keep that blade, the pilot orifice, in the center of the stream, and also about 1/2 of that diameter away from the nozzle opening, the butt of the hydrant, to get a good solid pressure reading. Now, I don't know about you folks, but in my department, the handler or the operator of the pitot pressure usually had something to do with seniority, such as the rookie got to work the pitot gauge. And after a few times, we'll figure out how to do that without getting absolutely drenched with water. So another thing we have to determine is the outlet diameter, which in most cases is going to be 2.5 inches, but we also need to determine that coefficient. Now, within the system, you'll see how this is a very, very easy prospect to get the coefficient, but we have 3 different types typically. The outlet with smooth rounded corners, we have an outlet with square and sharp corners, or in a very old hydrant, one that protrudes, where the nozzle protrudes into the barrel, and that will give us a coefficient of 0.7. And using the formula down below, Q equals gallons per minute divided by 100, 29.84 times the coefficient times the diameter squared times the square root of the pitot pressure will give us our gallons per minute that we're actually flowing from that particular hydrant. Now, some folks will actually take caps off of both sides of the hydrant to take this reading. They just have to double the gallon per minute values when they enter it into the hydrant flow test record. With the results, this is the formula that we use, and this is the formula that emergency reporting uses, straight from the NFPA 291. So we're going to get a flow predicted out our desired residual pressure. The desired residual pressure that we shoot for in our default setting is 20. And I see a couple of folks have put in a couple notes here about my voice dropping in and out. I usually do not have an issue with that. I don't know if I have a loose connection. I'll try to hold on to that to see if that improves that as we go forward down here. And you can see we get our other various pressures, our static pressure, our desired pressure, and our residual pressure. And all those values get plugged in, and we will obtain our flow results, what we can predict, which is going to be a flow from that particular fire hydrant. And the last slide, I don't want to bore you with these altogether, but NFPA 291 in section 4.13, public hydrant testing and flushing. 4.13.1, we want to do a flow test every 5 years. That coincides nowadays with the recommendations from the ISO. And also they want to see a flush test in section 4.13.2 annually to verify the operation, address repairs, and verify the reliability of the fire hydrant. So that is one more slide. We want to classify and mark our fire hydrants. So we have 4 different classifications. Class AA is greater than 1,500 gallon a minute. We note them as light blue. Class A is 1,000 to 1,499 gallons per minute. is a green color. Class B, 500 to 999 gallon per minute, is orange. And Class C hydrants, less than 500 gallons per minute, we will mark those red. So as we're going through our test results right here, I'm going to cover this. First here, this is a main system that we have here, and this is looped in this example from both sides. Our example here indicates that we have a pretty good grid, several hydrants along that particular main with water available coming in both sides of the grid. So we put our gauge on our test hydrant, exhaust the air like we're instructed to, and take our static pressure reading, and it's 50 psi. I'm going to translate these all into the record in the system in just a few minutes here. So we open up flow hydrant number 1, and we notice that we have a residual pressure of 40 psi at our test hydrant, so that's less than a 25% drop. And our pitot pressure from flow hydrant number 1 is 37 psi. So at that point, we would take a look at this and say, well, we need to open up another hydrant to get that residual pressure to drop a little bit. We need that 25%, so we need to go down a few psi yet. Hydrant test number 2. With our test hydrant in the middle again, same static pressure. Now we've opened up flow hydrant number 2. Our residual pressure is 30, so now we're at a good spot here where we're greater than 25% psi pressure drop. Flow hydrant number 1 has a pitot pressure of 35, and flow hydrant number 2 has a pitot pressure of 32. So we're going to take those numbers, we've got them jotted down, and now we're ready to go in and record our test. So what we're going to do is go over to my other screen and bring her on over here, and we are going to actually go to the map view. I want to at least demo the map view in here in case you don't have the mapping option. If you like this after what you see here, you can work with your sales rep to get this. It is an add-on cost. In my department, we definitely upgraded to this, and it proved very, very beneficial on several reasons here. So we're going to come in and we're going to zoom in and show you at these particular hydrants. This is our test hydrant that we're going to have, test hydrant 168. So we're going to give it a good old mouse click over top of that hydrant, and it's going to show us the basic information of it, location, that it's in service, what we're calling it, and you can see that we have an unknown pressure test. That's why we have the yellow color. If you look at the legend over to the right side of the screen, untested, these hydrants are yellow. And after we give it a record our test records, we're going to get one of the color codes to pop up on here, and I'll show you that just a little bit here. So if I come up to the hydrant with the gauge on it, mouse over it, and we have a flow test pops up, gives us a good guide where to go. And we'll select that icon and come over here and select to add the flow test. And remember, we're in hydrant number 168. So this is our flow test page for this particular hydrant. It will default setting into the date and time that we selected. And this time came up as Pacific time. Tested by me, since I'm logged in, my name will pop up here, but you can't manually type in a name. And if the name you manually type in here, by the way, is someone that's not in your roster, the system will remember them and they'll be available if you start typing it again to select from. So at our test hydrant, we're going to go ahead and start putting in those values. We had a 50 psi residual in our first test, or we have 50 psi static, 40 psi residual. You can see the desired pressure will auto generate to 20. Now my downstream hydrants, and if I look at my notes, the downstream hydrant number is for reference purposes. So we used my hydrant number 166 to get this reading. And my port diameter is 2.5. Friction coefficient. So we just have to look at this, our little picture that pops up here, and pick out which one we have. And in the town I work in, which is actual account is generated from. We all have, every hydrant is a 0.9 coefficient. So we just from the diagrams, we pick the correct hydrant, and we'll put in that pitot pressure that we have of 37. And you can see with this configuration, we have a 1,846 gallons per minute. But since our residual pressure did not go down more than that 25% that we're looking for, we're going to add an additional flow hydrant. So I'll come below here in my flow hydrants, select to add another one. And in this particular case, the number I need is number 339. And we have a 2.5 inch port diameter. Our coefficient is again 0.9. Pitot pressure, when we opened that second hydrant up on this one, was 32. Let me go right up above this and edit this and make it 35. And I will come up here and change this to 35. So you can see how significantly it affects our test results when we get this 25, at least a 25 psi pressure drop for that hydrant, and that formula calculates it out to 2823 instead of 1800. So that's fairly significant. So that's why we want to try to be as accurate as we can to get us good pressure from the hydrant. And remember, the system is designed to operate off of the guidelines of NFPA 291. So in this particular case, we would come down and select to pass the hydrant test, give it a date and time, remarks if we need them, and save it. Now we're going to go out to the hydrant record, and then we'll go back in and show you this is the record of that flow test. Now if we go back out to the grid, let's go back to the grid first and switch to map view, and we'll zoom into that area. Center that up for us, and we'll go a little bit more, and you will see hydrant 168 is that one that's showing up blue in the middle of the screen there, which coincides with the color codes in our legend over here to the right side of the screen. So that's what it will look like on the map view. Now, one question that we get a lot, an extreme amount of questions about this, and it comes up to, well, what if we don't use NFPA 291 to calculate our flows? We use a modeling software of one sort or another, or we have a different method to calculate our flows available. How do we indicate that on the screen? Well, first of all, no matter how you calculate it, whatever you put in as the gallons per minute, they will color code to the 291 standards, which are the red, orange, green, or blue colors. What I'm going to do is select the hydrant next to it, which happens to be 339, to show you what we would call a workaround for that. So let's say in your particular case, you have a fire hydrant that you test using some modeling software or some other method, but you have achieved a gallon per minute flow that you want to enter into your system. So we're going to add the flow test. We're going to do it. And here's the trick. If we put in for static pressure, and you may have a static pressure reading that you could put in, but at a minimum you want to put in 2, a residual pressure of 1, and make sure a 1 is in the desired pressure, you can actually come down to this field down below, the volume at desired pressure. In the case of you using a modeling software or other test method, and you have determined that that hydrant has a, let's say, 965 gallon per minute discharge calculated. Come down here and select my finishing results. These are optional, by the way, and save that. And you'll see what will happen when we go out here, back out to our grids. It actually will save this data, and that's the important number that we're looking for. Whatever way that you determine their flow calculations other than 291, simply do that 211 and then enter the value in that volume at desired pressure. If you select down here where that 0 was, you will be able to manually enter that flow in. Now we'll go back into our grid, and you'll see if we zoom in on that area that we've got that color code will pop up. Get that centered. And here we go. That tried to jump all over the place on me. Here we go. So it color coded as orange because it's more than 500 gallons per minute, but less than 1,000 gallons per minute on that hydrant test. So that's basically the long and short of recording hydrant flow records. It's a one-for-one thing. There is no bulk operation to actually enter those flows. You have to have your numbers and enter them in. And I've got a request from Mac is out there. He was able to jump in. And sorry if I didn't see you before, Mac. And Mac, that is not allowing me to do that. Oh, here we go. There you go, Mac. Okay.
Thank you, sir. I'm here.
Okay, perfect. So what we're going to do now, I've got a question from Justin. Could it speak to a few highlight points of the map view? Sure. So this map is, again, like I said, you have to speak to your sales rep. It is a add-on feature. And they get you hooked up with that. And what you have is the map view. Let me cover that real quick for you. You can switch to the map view, not only in the Hydrants module, but in the Incidents module. One of the nice features of the Incidents module is you can have this heat mapping as the default setting, locations of your incidents. It also is viewable in the Occupancy module. In the Occupancy module, I'll have to zoom in a bit, but you'll see we have some icons. And when I zoom in here, you'll see the icons will just be displayed. Let me show you a section downtown here. And then we have, some of these are some different colors. And this is because I have a vision on this, which are OVAP scoring, which is another upcharge basically to have that product. However, you can view it there with every occupancy will be here, illustrated by the little buildings. And the nice things about this is you can also overlay the hydrants on here if you'd like to, as we just did here. It works best if we zoom way on in. Pretty much like that. Can get kind of busy though. And also, of course, the map view is available in the Hydrants module. So, and then again, switching to the hydrants here. So I know we've got a few questions that have come in. I want to try to get to everybody. I do understand that my mic was cutting in and out. I apologize for that. So Justin, that was hopefully a quick little tour of the map view. One of the things that's really nice about the hydrant module is if you're in the map view and they install a brand new hydrant in your community, we do have a button right here at the bottom of the page where we can select to place a new hydrant and put it out on the map, give it an ID number, and save it. And it will locate that record and generate a record right for that hydrant on here. That's another little feature that we have that's somewhat newer that I want to show you real quick, is that if you, we're going to start from the grid here. If you add a new hydrant, we do have a new feature, newer I should say, where you can use this fill from current location link. Now I'm located in Greenville, Ohio. So when I pick that up, you'll see that you'll be using the location from the device you're using. And in my particular case, that's exactly where I am. So if I just select to save that, it's going to put that in and put the latitude and longitude in exactly. Now, however, it's not too accurate with the PC. If you have a device that is GPS enabled, most usually a tablet or a cell phone size device, they are more accurate than a PC would be. And it'll use those locations. If I select this map right here, you'll see that that pin, just believe me, is exactly where it needs to be. But I mean, it's right from where the computer is, which is right in the middle of my house, not where the hydrant will be out on the street. And that's where you're going to get that accuracy from your handheld device on that. So that's how we would add a hydrant with that little feature. And so I hope that was a little bit of a tour for you, Justin. Okay, so Mac is helping out here and answered. John had a question. We recently had ISO at our agency. They requested for fire flows to have one test hydrant and to open the 2 ports of another hydrant to get flow. Is that accurate for testing? It can be, but John, what you would have to do is, let me show you one method here, John. I'm just going to go into this out of service hydrant right on my page here. So if we went and added a flow test for that particular hydrant, and let's say we had a static pressure of 52, a residual pressure of, let's say, 35. So we got at least our 25% drop. What you'll have to do is that hydrant that you opened up 2 ports on, you'll have to put 2 records in. So assuming you have a 33 PSI pitot reading for the 1 open butt, you'll have to add another flow hydrant, let's say side B of it, put the rest of our data in. That's how you would do that particular case when you're doing your hydrant testing, when you're opening 2 butts on the same hydrant, 2 flow ports. So you have to double them like I did here in that case. I'm going to go on down here a little bit and see if we can answer a few more questions. Ken is asking, what if we don't do a second or third hydrant? You get all your readings from a single hydrant, then go on to the next one. Well, Ken, a lot of people do that, and actually in my department we did that. And it's simply usually a staffing issue of having enough time to do it correctly. I'm just going to tell you that, hey, it works. You can put your readings in here and it will calculate out to those readings you have. It just becomes much, much more accurate when you get, if you can achieve that 25% drop, at least in that residual pressure from the static pressure. Everything becomes much more accurate at the calculated flow that you're going to get.
Hey, Mark, if I can add, I think we've got several of those, and what you're looking at is what they want you to do on ISO. I responded back to John earlier. You can look on ISO mitigation website, and it'll sort of tell you more about what they're doing, but what they're looking for is a downstream hydrant. If you turn it on, just 1 port or whatever in there, or whatever you have to do to get that drop, like Mark was just talking about. And then you can test all your hydrants on that particular line, and you can use the same hydrant if it's downstream. So the end of that line is what they're looking at. But like Mark said, in my department, we done them all just one at a time, just because of our numbers and people, and we didn't want to lose that much water just flowing that one all the time trying to test a bunch of hydrants in there. So that's the way we done it. There again, if you get with your ISO mitigation on the website or your ISO rep, they can sort of help you there and sort of guide you exactly how they want it done to get you the max points there.
Okay, perfect. Thanks, Mac.
That's all. Mm-hmm.
We're going to go on down to John Lundgren. Ask a question here about, what about the diverters with gauges? Are they accurate for the pitot reading? I think they are, John. I think you have to be careful with those. We had one of those in my department. What we found in parts of our city's water supply system was very old, and we would occasionally get some debris, actual small flakes of the pipe, the old cast iron pipes actually. And when some of that would discharge out through that device, it would actually hit the pickup pitot tube in there and bend it. So that can become kind of a problem. All of those will have, hopefully when you buy it, they'll tell you what the coefficient is for the friction. But now in our particular system here, though, we only give you 3 choices. We give you 0.9, 0.8, and 0.7. So with one of those devices, I would switch it over to 0.9 and just leave it at that. You're going to be pretty accurate with that. Some of them do have nearly a 1.0 coefficient, but there's no way for us at this point to note that within here. So I would just select a 0.9. Okay, so we're going to go on down to
Mark. I can answer Jeff if you would like.
Oh, sure.
Jeff, not exactly, Mark. I don't know if you're familiar with that ESRI collector
Esri.
data.
Oh, yeah.
Esri. Oh, okay. Esri. Yeah, I am. I wasn't thinking there. I'm sorry. New year, you know what I mean? But yeah, I mean, if you've got Esri data or Esri, if you can get it out in some form of Excel file, then yes, we can import it into ER. If you need help with that, please just give Mark or I shoot us an email, and we can assist you with that.
Yeah, Jeff, to reaffirm what Mac's saying here, we do have the import tool that is available to administrators. You get it in your Hydrants module. Go to settings, and we'll go into settings, and you do have the ability to import your hydrant data. There's a link on this page. You do have to have admin rights to get this because it will take you to the admin page. And there is a template available in that import tool that you can use. Basically, you would need to take your data and copy it column by column and put it into that spreadsheet. And this is what we would call a customer-facing import. You can do that on your own. Now, if you do need help with it, we'll be happy to help you. Just shoot us an email. And I skipped Bill because I knew what you were talking about, Bill. He was asking about, how do we record our annual flushing? And I figured that was going to be your question. Instead of doing a real hydrant test, flow test, I can give you a quick little demo on that because I was going to go there anyway. I want to go back out to the grid, and we're going to go to that hydrant that I was using. I think the number was 268, or no, it's 168, sorry. So I filtered my whole entire list by this one particular hydrant. So there's a couple things that we can think about here, especially if you're wanting to schedule them. Like in my agency here, we did all of our hydrant testing and flushing in the month of June. Using the power of emergency reporting, what I'm going to show you is that I'm going to select this particular hydrant. Now imagine this is 400 or 800 hydrants. Whatever it would be, you could split these up by different districts and zones within your agency and use this bulk operation tool that we have available to you. We can schedule maintenance. When we schedule that maintenance, you'll see that we can set up maintenance interval, one of which can be an annual flushing. And let's say we're going to start this first maintenance. We're going to be pretending like we're Todd up there in Alaska. We're not going to be afraid to do this in the middle of the winter. And we're going to schedule that for 1st of January 2020. And what the system will do then is any hydrants in this particular group, it will auto-generate the work orders for us, whether it's 1 or 1,000 or even more for that particular start date that we started out. And eventually, if we come over here to work orders, we're going to see the particular work order auto-populate here. And that's how we would do that, Bill, is we would record that as a flushing inspection or whatever language you're using there locally for that. Now that'll pop back up here. I think what we'll do is take a look at, it's just going to take the system a minute for that to go through. So let me actually go into settings to show you how to set that up. So in settings, we do have maintenance types. So here you have maintenance types here, and I've got in here one called flush test. And then we would set up our maintenance intervals. So you can see I have a whole number of them in here. So if I was setting up a brand new one, such as like as annual flushing, we're using that maintenance type of flush test. I set my duration once every year, and alert days. In this case, I've got 30 days here. So if I put in a date that I want to start this, 30 days prior to that date, my work order is going to get auto-generated. Then I have to add that maintenance interval to each hydrant that I want to start that with. So with going through all that discussion there, I'm hoping if I go back to the work orders, that it would have generated that work order for me. And sometimes it takes a few moments for that to go through the system when we're doing a live demo of this. And it looks like it still hasn't auto-generated it. We'll come back to that in a moment. So that's how we would do that. We could actually even set up our 291 flow test doing the same thing. Set them up. There's a 5-year interval. So now we have it. So I was trying to talk and stretch it out a bit so you can see that I did get my annual flushing that I just scheduled. And now if I had, let's say, in this particular case in our city here, we have nearly 1,000 fire hydrants. We would just be able to go into, select the ones that we did that particular day. I've only got one displaying on the page. Now we have a bulk operation to complete those work orders. And show you that we did it on today's date. And you can put cost figures in here if you need to, maybe some time, and complete those work orders. And you'll see now, if I select yes on this, that could have been, let's sort this by my completed date. Here we go. And that one should be here, completed, yes, that's the one I just did. And within the Hydrants module, there's some very, very efficient filters and capability to do bulk operations, to generate work orders, to add maintenance intervals to hydrants, to complete work orders, and all those functions. And it works really, really well. So hopefully, Bill, that is answering your question about that. And Jordan asked about importing data with that CSV file. It's you need to use our template with that, Jordan. And John asked, is there any way to pre-fill the hydrant information such as port size and coefficient? No, there is not. So unfortunately, you have to type that in and make a selection every time. And if you're really, really interested, I hear that quite a bit. In our system, if you go to the support page, into the community forums, into the feature suggestion area, search for that one. I know it's in there, and put some votes onto it, put some notes about that in here. And Mac is correct. Just so everybody, we're going to catch everybody up with this question. Jordan asked or mentioned that you have most of the data in the template, but some fields you don't have. Can you import only what we don't have? Yes, you can. You can overlay that. It does work into the Hydrants module. And Todd, he's saying, oh boy, it's 0 degrees today. Yeah, we'll come up and test some hydrants with you, buddy.
Yeah, I told him we'd skip that, Matt, or Mark.
Yeah. I am very used to cold temperatures where I live here in Ohio. It does get cold. However, we're not going to go there. Although, Todd, I will be going to Idaho in late February, so I think it'll be cold enough for me.
Yeah, I've got Montana in the middle of this month. So.
Oh wow. Yeah, I've been to Montana in the wintertime too, and North Dakota, so we're all experienced with it. But
oh yes.
Todd, you can have all that hydrant testing in the wintertime.
Got a follow-up from Jeff about doing, let's see, he's talking about if he would do a bulk import, it overwrites any previous data. Is that still correct?
Well, Jeff, I can answer that for you. If the field is empty, it does not overwrite the data, but if there's any text into it in that field at all, it will overwrite to the previous data.
Yeah, I think that came from another one. Jeff, I believe that was you that I answered earlier we were talking about. So you can put it in and you can go ahead and fill in what you have if it's not completed. Then when you do your other one, when you get more data put in there, if you'll take out what you've already put in for that form, that CSV file, then when you update it, as long as your hydrant IDs are the same, it will just add that new data to it. And if it was the same you did before, if no changes, it will still be fine anyway, because it's not going to override if you didn't change anything. It's just going to put it in again. Okay, hopefully that answers your question there, Jeff. If you've got anything else, let us know.
Yeah, Jeff, the main thing is if the field is empty on a hydrant import, it won't affect the text or any data in your current field. If there's data in it, it will change it to the new data. And let's see, we got one more that just came in. No, Justin, unfortunately, there is no bulk import for all those things. You have to do flow testing and input the data one hydrant at a time. So if you want to have a bulk operation for that, please go to the community forums, to the feature suggestions area. You might want to search for that one. I do not know if that is in there currently or not, but a bulk operation and flow data.
I don't think it's in there yet.
So Justin, here you go. You got first shot at it. Don't forget to put some votes on it and ask all of your friends to put votes on it too, and put some comments with that as well. And let's see, I'm just trying to make sure we addressed all of our questions. Mac, and thanks, Mac, for jumping in.
I do apologize. It was no problem. I apologize. I wasn't here earlier. I had another call I couldn't get away from in time. So.
And just to everybody know, our new guy is on board with us. Good afternoon, James.
Hey, James. How are you, brother?
This is day one for James. So we all need to be nice to him, right, James?
For this time.
Yeah, you know how we're all firemen.
Yes, sir.
We're all firemen, so you know how that'll work out for you, right? Anybody else that has any questions out there, please throw them at us right now, because we'll give you another moment or two, and then we're going to put this one in a record book. I hope it was informative for you today, and we will do some editing on this probably later today, and it will be in the webinars on demand section, hopefully very, very soon, so you can refer back to it or let other people know that they can learn a little bit on emergency reporting.
Mark, I don't see anything else. You did hit the few highlight points of the map that Justin was talking about earlier?
Sure. Oh, yeah.
Okay. Yeah, I don't see any other questions, brother. I think we've covered everything.
Okay. Well, we are going to let just one more moment pass, and if we don't see anything, we'll put her in the record book. And I appreciate you jumping on, Mac, as always.
No problem,
James,
sir.
It's great that you're able to jump in for a few moments for a first peek. So I think we are going to
have. So when we add or remove hydrants, how are they entered?
Okay, so when we add or remove a hydrant. Okay, let's go a real brief lesson on adding a hydrant from the page. I have my grid filtered by Hydrant 168. Let me remove that. And we're going to be looking at the grid. And in this particular case, in this account, I'm looking at the bottom right corner. You can see there's 920 hydrants in here, which is kind of a side little issue. So I just wanted to show you that about the grid. We're just going to simply select add a hydrant, this link at the top left. And we're going to start on the location and info page. Now, if you're using numbers and numbers alone for your hydrants and you don't really care what order they're in, select next ID, and what the system will do is go out there and look for the biggest number and add one to it. So here we've got a pretty good sized number. So it found that out there, 78, 78, 78, 78, and added one to it. We're going to select that it's in service if it truly is, and put a location description in here. And whatever that might be, because fire hydrants are not always at address locations. And again, if we're using the fill from current location, now this works best from a GPS enabled device like a tablet or a phone. When you're out in the field, you can literally stand at the hydrant. You can either update the latitude, longitude coordinates, or add a new one from here, and this will give you some suggested addresses. And you can see it just jumped a little bit on me here, but this is where I'm at. We're going to save it, and it's going to bring in that particular address. And you don't have to really worry if the correct street is in one of those selections, because you can manually override it right from here. The important thing is to get good latitude, longitude coordinates. And you want to verify it. If you have the mapping software, you want to verify it just by looking at the map. And I can tell you that pin is pretty much exactly where I'm sitting, but I want to move it. Let's say it's out here at the other side of the street. Just that simple. We've updated our longitude and latitude. Station, zone, and districts at the bottom of the page. And when we save that, we've got the hydrant record started. And you can go across to the other tabs, details, flow test, schedule maintenance. Just that simple, basically. So that's putting one in. So let's go in and take a look at this one. I want to show Curtis how to delete a hydrant. So I'm going to go find that one I have in. I'm just going to type the 7878. I hope I got them all. Maybe not. That should be most of them here. So I just put this one in. To remove a hydrant from the list, we just come out here to the trash can to delete the hydrant and select that to archive it, and it goes away. And I have where it pops up as archive, so I can see all of them. It really, in this particular case, it did not pull that back up, so it must be a hard delete now. That may have changed recently. And Mac put a link into you for the knowledge base article. Thanks, Mac. And Justin, can you explain how to submit a request, please? And I assume, Justin, you were talking about in the support pages in our chat or our community forums. Let me go on in and okay, so you have to log into the support page. It takes a special login. To get to that, anyone in your department can get a login for support. If you don't have one, there's a little link up there that says sign up on that first page. Community forums. At the top of the page is that link, and here's the section for feature suggestions. Select that, and you'll select a new post up here. So I'm going to put in the word flow to see if we pop up with, whenever we do a search in here, the community forums are going to be on the right side column. Let's see. There may be one in here. I'm not going to scan through every one of these. But yeah, we have a couple pages that won't take too long, so we'll take a look real quick here. And I don't think there's one in here, so we'll go back to the feature suggestions. New post right here. Select that, put in your information, talk to your friends, family, get them all to log into ER, go to our support page and give that a vote. When you're looking at an idea, and I'll go into read this first section here. Over on the right side of this, there's little up arrows and a down arrow. The more votes our developers see, the higher the likelihood is that that request is going to get developed. That's, yeah, Mac had just answered a question. What is the reason for archiving a fire hydrant? So if we go into advanced search, thanks for reminding me, Mac, I am actually going to search all hydrants, status, archived. Make sure I'm going the right direction here, Mac.
Yeah, it's just for if you ever need to retrieve that, say you want to pull it up or you had a fire there in the past and or somebody wanted to know what it was for some reason, they took it out or something like that, you can actually pull that information back up for that hydrant that was removed for some reason.
All right, perfect. So hopefully that all helped everyone out. So we'll give it another moment here. A couple of really good questions right there at the end.
Absolutely, yeah.
Appreciate that. And we'll wish everybody a continuing Happy New Year. Hope you get all your goals accomplished this year, personal and business. And with that, I do not see any more questions coming in. So we're going to go ahead and put this in a record book. And we appreciate everybody for attending today. And maybe we'll see you next month. Thanks a bunch for attending. Have a good day.
Bye-bye, everyone.